Look, we kinda have to admit the stark biological reality here. Compared to almost every other mammal out there, human newborns are undeniably poorly equipped for survival right out of the gate. Their heads are disproportionately huge, they completely lack the neck muscle control to actually support that heavy head, and they are 100% dependent on their caregivers for absolutely everything. So from a strictly biological perspective, yeah, they seem entirely helpless. But, as our sources reveal, there's actually a hidden layer of profound genius operating right beneath the surface.
And that hidden genius? Well, it brings us to the core focus of today's explainer: inter-sensorimotor action anticipation. Okay, I know, that is a massive, textbook-heavy term, but stick with me because we're going to break it down right now, and it leads to a genuinely mind-blowing realization about how we develop. At its core, this concept just means coordinating your physical movement and your sensory input to actually predict and prepare for an outcome before it even happens. It's not just reacting to the world after the fact, it's anticipating it. Keep that crucial word in your head: anticipating.
Now, check out this ultrasound data. It's capturing fetal arm and hand movements directed toward the face, recorded between 5 and 9 months of gestation. Researchers tracking this specific data found something that is just astonishing. More than half of all the observed arm movements in these early stages resulted in the baby's hand smoothly touching their mouth. But here's the kicker: they aren't just randomly bumping their hands into their faces hoping for the best.
And here's where it gets wild: the anticipatory mouth. The data shows us that the fetus actually opens its mouth before the hand makes contact. Let that sink in for a second. They are not just flailing around in the dark until a thumb accidentally hits a lip. They are actively predicting the hand's arrival. This proves that complex coordination, that exact inter-sensorimotor action anticipation we just talked about, starts in the absolute pitch black of the womb. They're planning and preparing for a physical interaction way before it even happens.
You can see it perfectly in this 3D ultrasound showing a fetus resting its thumb right near its mouth. This isn't just some cute picture for the fridge, it's literal scientific evidence of a soft-assembled dialogue happening between the physical body and the rapidly developing brain. The baby brings its hand up, anticipates the touch, opens the mouth, and completes this highly coordinated sensory and motor loop. Sensing, moving, and anticipating are already working together in perfect harmony.
Alright, so we've seen this hidden genius happening in the dark of the womb, but what happens when the baby is actually born? Let's transition from the womb out into the real world and ask, how does this movement actually play out? How do scientists view the ongoing development of these complex anticipated movements once gravity, light, and physical objects are suddenly dropped into the mix?
Well, to really get this, we have to look at how scientific thinking has actually shifted over the years. Traditionally, the older theory basically treated the brain like an isolated computer, like it was up there processing complex mathematical equations, estimating the exact angle, distance, and speed of an object before commanding the body to move. But nowadays, we look at the dynamic systems view. This shifts the focus entirely to real-time adaptations and moment-by-moment interactions with the environment. Think about trying to catch a falling pencil off a desk. You don't pause to consciously calculate the geometry of the fall, right? Your body and eyes just adapt in real time, adjusting your hand seamlessly as the pencil drops. That rich, physical, real-time interaction, that's the dynamic systems view in action.
And we see this dynamic interaction so clearly in early infancy through something called hand regard. After birth, right around 3 months of age, infants will literally just lie on their backs and spend sustained periods visually exploring their own moving hands. It sounds super simple, but biologically speaking, it's profound. By watching their hands move right in front of them, babies are continuously linking the look of the movement with the physical feel of the movement. They're actively learning that they are at the center of their own actions, tightly binding perception and action together.
Let's break down how this actually builds, because it brilliantly illustrates how hitting a physical milestone literally constructs an advanced cognitive ability. Look at this sequence. Step 1, an infant learns to sit unaided. Because they no longer need their arms to just simply prop themselves up against gravity, we arrive at step 2. Their hands are completely freed up for highly active visual and manual exploration of toys and objects. And here is the truly amazing part. Step 3. Researchers found that this specific physical experience of sitting and exploring directly predicts their future ability to mentally rotate 3D objects in their minds. The physical action literally builds the cognition.
And if we map this out over time, the long-term ripple effects are absolutely wild. At 5 months, you've got active, efficient manual exploration of objects. But it doesn't stop there. Moving to 9 months, we see this physical exploration evolve into sustained attention, By 12 to 15 months, that sustained attention directly correlates to an increased, much more complex vocabulary. And, remarkably, studies even show that the efficiency of a 5-month-old's motor exploration actually correlates with their higher academic achievement all the way up to 14 years of age. The way they learn to move their hands and interact with the physical world directly impacts their academic success a full decade later. No way, right?
So, let's pull all of this together. The massive takeaway from all our sources today is this: action is cognition. First, while newborns might look entirely helpless on the outside, we've seen that they actually begin complex, calculated prediction while they're still in the womb. Second, that fetal thumb sucking, it isn't random. It absolutely proves inter-sensorimotor action anticipation. Third, the dynamic systems view shows us our brains aren't just doing math in isolation, they are linking real-time physical movement directly to cognitive learning. And finally, early motor milestones like sitting and reaching are the very building blocks that shape long-term vocabulary and advanced spatial thinking. Sensing, moving, and thinking are fundamentally inextricably intertwined.
I want to leave you with one final thought to chew on as we wrap up this explainer. If your absolute deepest cognitive abilities began with a simple, unanticipated thumb-to-mouth movement in the pitch dark, how much of your brilliant mind is still being shaped by how you physically move through and interact with the world today? It really makes you rethink the power of your own physical actions, doesn't it? Thank you so much for joining me to explore this incredibly cool topic. Stay curious, keep exploring, and I'll catch you in the next explainer.